are going to talk about kinematics in one dimension, part 3. This is the continuation of our lesson on speed and velocity. So today we are going to talk about acceleration. Okay, so first, what is acceleration? So it is a change in velocity, and acceleration can be speeding up, slowing down, or turning. Okay, so in this case, since we are in one dimension, so we are going to have the speeding up and then the slowing down. Okay, so we will have a separate discussion on motions with two-dimensional or three-dimensional siya. Okay, so here you can see images or yes, photos which you can refer if you're accelerating. It is because you're speeding up, and then also you can consider acceleration if you're slowing down, and then also you can still accelerate if you are changing in directions. Okay. So what is uniformly accelerated motion? So in this lesson, we are going to focus on the uniform acceleration or the uniformly accelerated motion. So which means that the acceleration is constant. Okay? So if your acceleration is constant, we have this equation. Okay? So acceleration is a vector quantity. That is the reason why we have an arrow at the top of letter A, small letter A, is equivalent to delta V over delta T. Again, this delta means change in velocity over change in time. Okay? Or your final velocity minus initial velocity divided by final time minus your initial time. So that's the reason why we have this delta with this small triangle here. So this is your velocity. So since we have here velocity over time, so the SI unit for acceleration is meter per second squared. So naka-square na si second. It's because you are going to multiply your time from your velocity and then time for your overtime for your acceleration. So that is why we have this unit for acceleration. So here in the animation, you can see here a car is moving and then its velocity is changing. Okay? Ayan. Your acceleration here is constant. All throughout, your acceleration is 1 meter per second squared. Pero yung velocity ninyo, nag-change siya over time. You have your 3 meters, 4 meter per second, and then it's stopped here. Okay, so babalik ng 0 si velocity once your car stops moving. Okay, and then yes, another animation for the uniform acceleration. Ayan, your uniform acceleration here is 0.5 meter per second, or this is just your s squared. Okay, and then your velocity changes over time. Ayan. So it means na yung tao dito naglalakad siya faster than its initial velocity. Ayan, mas bumibilis siya. That is now your acceleration. Okay? Since your velocity changes every second. And then here, your acceleration also has a positive or negative. That indicates your direction. Okay, so importante si positive and negative in your acceleration because acceleration is again a vector quantity which needs direction. Okay? Now if the sign of velocity and the sign of acceleration is the same, so kapag your velocity and acceleration is going in the same direction, ibig sabihin, your object speeds up, okay? Or bumibilis si object. While if the sign of your velocity and the sign of acceleration is different, bumabagal naman si object, okay? Or the object slows down. Okay? Usually, if your velocity and acceleration is not on the same direction, so yung object natin bumabagal. So that's the sign or the importance of positive and negative when we are determining your acceleration. Okay, so there are four kinematics equations. So these are the four important equations. So it is not necessary to memorize this equation, but you have to familiarize this equation. All of this have different uses. Okay, so magkakaiba yung gamit ng mga equations na ito, okay, depending on our word problem. So this is quite exciting. It's because we will have more problem solving, and then the level of difficulty of these problems are a bit higher compared to our previous solving problems. Okay? So the derivation of these equations will be shown in the next slides. So here for the derivation of equation 1, so we have your original equation for the acceleration, that's delta v over delta t. Okay, we indicate your final velocity minus your initial velocity. Again, kapag meron siyang sub na zero, okay, dito sa ibaba, it means initial velocity. Okay, and then your time t minus t naught, okay, or t sub o, t sub zero, or your initial time. Okay, so usually your initial time, if you are in a starting position, it is understood na zero yung initial time natin. So this is why we have v minus v naught over time. This is now your equation for average acceleration or your acceleration. So the same lang yan siya dito, equivalent lang yan sila. Okay. Iba lang yung form niya. Now, if you multiply both sides by t, or i-transpose natin si t dito, you have now v minus v naught equal at. Okay, and then I will transpose this negative v naught to this side, or sa right side. Okay, so you will have this equation. Okay. And then it shows your velocity as a function of acceleration and time. You can use this equation when you don't know or when you are not asked for the displacement. So kapag walang given na displacement, pero merong given na initial velocity, acceleration, and time, you can solve your problem using this equation. Okay, so yun na yung gamit ng equation. Okay, for the derivation of equation number 2, you have here your equation for velocity, that's delta x, or this is your displacement over time. Okay? And then dito, if you can observe, sa velocity, wala na siyang, i-disregard na natin yung arrows on top niya. So it's okay, since interchangeable naman sa speed and velocity. So it is okay to not have the arrow sign at the top. Okay. So we have here, since velocity changes at a constant rate, we have this equation, okay, and then gives displacement as a function of velocity and time. You can use this when you don't know your acceleration. Okay, so kapag hindi na given sa acceleration, you can use this equation to solve for your distance or your displacement. Sorry, that's displacement. Okay, and then derivation of equation 3, you have here, this is now your equation 3, this is the process. You just substitute this v dito na v. Okay, so that is why we arrive at this equation number 3. Okay, so it gives the displacement as a function of all three quantities, the time, initial velocity, and acceleration. You can use this when you don't know and aren't asked to find the final velocity. Okay, and then for equation 4, you go through the same process, you substitute, and then you transpose the equations or the variables. If you're going to rearrange it, you will arrive to our equation 4. You can use this when you don't know or aren't asked for the time. So itong derivation na ito, I only showed you how we derive these quantities, but it is less important when it comes to solving problems. So ang importante lang na tandaan ninyo is this four equations. Okay? So I wanted to show you how we derive it, pero I think I'll make a separate video or I will discuss it on our next Zoom meeting kung paano derive the kinematics equation. I'll think about it if necessary ba siya for you to know or yes. But this is the most important or the most significant part. This four equations. Okay, so if you don't have questions, we will proceed with the free fall acceleration. So ano naman yung free fall acceleration? What we have discussed is only for the horizontal acceleration. Okay? If you have an object moving in a straight line or along your x direction. Paano naman if we have along your y direction, okay, or from top to bottom? We have your free fall acceleration. So sa free fall acceleration, if your object is moving along your y direction, okay, or along y-axis, your acceleration is expected to be your acceleration due to gravity. Okay, ito na yan siya, or your letter G. Okay, I think all of you are familiar. This is 9.8 meter per second squared. This is the value for our gravity. Okay, so it is understood kapag si object is falling, okay, kapag nahuhulog si object, our acceleration is due to gravity. Okay, so gravity is given by 9.8 meter per second squared. Okay. So this is a special case for acceleration. So your direction is always downward for your acceleration. Si acceleration dito, kapag nasa y-axis tayo, is always downward. So always negative yan siya. Okay? So here, your acceleration due to gravity is equal to negative g or negative 9.8 meter per second squared. So don't forget, kapag nasa y direction ka, your acceleration is always downward and it is always negative. So importante si negative because it determines your direction for your acceleration. Okay? It is also independent of mass. Kahit gaano pa yan kabigat si object, your free fall acceleration or your acceleration due to gravity is always the same. Okay? And then important, kapag nag-solve tayo ng problems involving free fall, you have to pick an origin so that your initial position is equal to 0. Okay? So here, meron dito, this is the Tower of Pisa, and then merong old man here, tapos nag-drop siya ng ball. You can see here, this is a smaller one and then a big one. So regardless of its mass, kahit saan pa dyan yung mas mabigat, okay, they fell sabay. Okay, they fell sabay sa English. Basta they fell together. Ganon. They fell together and then it's because they have the same acceleration, which is equivalent to negative 9.8 meter per second. And then you can observe here, meron tayong axis dito. This is your y-axis, this is your x-axis. Okay, you can pick the origin here. Okay. Pwedeng i-pick natin si origin when as to where the object will fall, or you can also pick an origin dito sa itaas. It depends on your reference point or the reference point of the problem. Hi everyone, so today we are going to have series of examples on word problems involving speed, velocity, and acceleration. So here I am going to present different word problems and then different formula or what are the formulas being used in solving this problem. So for the first example, we have here, you step onto a hot beach with your bare feet, a nerve impulse generated in your foot travels through your nervous system at an average speed of 110 meters per second. How much time does it take for the impulse, which travels a distance of 1.8 meters, to reach your brain? So in this case, first you have to write your given. So here your given is a speed or average speed, sorry, that's V, equal to 110 meter per second. And then the other one is your distance. Okay, that's D equal to 1.8 meters. And then what we are looking for is your time. So how long or how much time does it take for the impulse to reach your brain? Okay, so in this case, we are going to use your formula for speed. That's V equal to D over T. Okay. Since we are looking for time, we are going to transpose your equation para yung time yung hahanapin natin. Okay? So in this case, you multiply both sides, okay, by T over V. Okay? Also here, T over V. Okay? So this is to cancel out your velocity, I'm sorry, your speed, and then your time, and this side. So sa left side, may iwan na lang si letter T or si time. And then sa right side, we will be left with your distance over your speed. So that is now your formula to look for the time. What the next thing to do is to plug in the given values. So you have here 1.8 meters divided by 110 meter per second. Okay? So dito, makakancel out si meter na unit kasi meron tayong meter sa taas, meron tayong meter sa baba. What will be left is your unit for your time, which is the seconds. So if you calculate this using your calculator, you will get 0.016 seconds. Okay, so that is now the answer for your problem number 1. So that's 0.16 seconds. So for our next example, we have here a fast object moves from point A to B, to C, and then to D, and then back to A, along the rectangle shown in the figure below in 5 seconds. So the first question is find the average speed of the moving object in meter per second, and then find the velocity of the object in meter per second. So here you can observe that the given distance in the rectangle shown is in kilometers. So what you have to do is to convert this kilometers into meters. Okay, since what we are looking for is meter per second. Okay, so the first step or the first thing to do is, again, you write your given. Okay, so your given here is for the speed, you have to look for the distance. So yung distance natin dito, given siya sa figure, you can see here that the distance traveled by the object from point A, and then it went back to this point again. So 5 plus 3, that's 8, plus 5, 13, plus 3, that's 16 kilometers. Okay. Now, since we are looking for meter per second, i-convert na natin siya into meters. Dito pa lang sa given, you will have now 1,600. I'm sorry, that's 16,000 meters. Okay, so this is equivalent to 16,000 meters. Okay, then the time it took for the object to travel this rectangle is 5 seconds. So okay na si time since it is in seconds. Now all you have to do is to solve for your speed, which is v equal to b over t. Okay, and then you divide, that's 16,000 meters divided by 5 seconds. You will get, okay, so that's 16,000 divided by 5, 3,200 meter per second. Okay, so this is how you write the unit for speed. Now what about the velocity of the object? Okay, so that's for letter B. We are going to look for the velocity of this object. Okay. So again, so velocity, that's a vector given by your displacement divided by time. So in this case, ano yung displacement ni object? Since the object, it went back to its original position, it is understood that your displacement is equivalent to 0. Okay? So since 0 si displacement, ibig sabihin, your velocity is 0 divided by 5, it gives you 0. So your answer for the velocity of the object is 0. Okay, so that's the velocity of this object. Okay, so magiging 0 lang siya when your object went back to its starting position. Kapag hindi naman, you have to look for its displacement. So dito, importante si time or si direction ng object. Now, we are going to have different examples, or I mean, two examples for the acceleration, okay, or problems involving accelerations. So for the first one, we have here a car accelerates from rest to a speed of 36 km per hour in 20 seconds. What is the acceleration of the car in meter per second? Squared. So here you can observe that the given speed is in kilometers per hour. Tapos yung hinahanap natin acceleration is in meter per second squared. So you have to go through converting your kilometer per hour into meter per second before performing the operation for the acceleration. So here, let's start with the given. You're given with a speed. Okay, so your initial speed will be 0. Bakit 0? Kasi it states here in the problem that your car is from rest. Okay? And then its speed up, or your final speed is 36 km per hour. Okay? And then you're given with a time of 20 seconds. Okay? So within 20 seconds, ito yung velocity ni car after accelerating from rest. Okay? So, since we are looking for an acceleration in meter per second squared, so i-convert na natin si speed, okay, into meter per second. So that's 36 km over h. Okay. And then, right here, you see your conversion units, we have your conversion factor. In 1 kilometer, we have 1,000 meters. Okay, so dito maka-cancel out na si kilometer, maiiwan na si meters. Now, what about the R? So, si R, para ma-cancel out, maglalagay ako ng 1 hour dito sa taas. Okay, and then in 1 hour, we have 3,600 seconds. Okay, how did I get that? In 1 hour, we have 60 minutes. Tapos, per minute, we have 60 seconds. So, you multiply 60 times 60, you will get 3,600 seconds. Okay? And then, you solve this using your calculator. Maka-cancel out si km, maka-cancel out si h. You will be left with meter and seconds. Okay? So, pag i-solve niyo yan using your calculator, you will get 10 meter per second. So yan na yung gagamitin natin to solve for your acceleration. So acceleration is given by delta v over time. Okay, so in this case, we are using speed. Interchangeable yan sila na velocity in getting our acceleration since speed ang given, ibig sabihin, wala tayong direction for your acceleration, but we have to go for the sign. Okay? Kung ano yung sign niya after solving this problem. So delta means your final velocity minus your initial velocity over time. Okay? Now plug in the values. Your final velocity is 10 minus 0 over 20 seconds. Okay, so you will get positive 0.5 meter per second squared. Okay, so the acceleration is positive. Okay, so here, regardless the direction of the speed, kapag regardless the direction of the velocity, if you are using speed, it is necessary that you have to understand first the problem kapag from rest yung car or yung object natin and then nag-speed up siya, ibig sabihin your car is accelerating. So positive yung acceleration natin. Kapag negative yung acceleration natin, ibig sabihin yung car ninyo, it slows down. Okay? Bumabagal yung takbo ng sasakyan. Okay? Now, for the next example, dito natin maa-apply yung another sign or the negative sign of our acceleration. It's because your problem is a car slows down from a speed of 72 km per hour to rest in 25 seconds. What is the acceleration of the car in meter per second squared? So here your given is a speed of, that's v equal to 72 kilometer per hour. Okay, and then this is your initial speed. Okay, kasi from a speed of to rest. Okay, so after the car, kapag nag-rest na si car, so zero na si velocity niya kasi nag-stop naman si car. And then we have the time, which is 25 seconds. Okay? Now, since ito, naka-kilometer per hour na naman siya, we have to convert this into meter per second. Okay? So, 72 kilometer over 1 hour or over h times, okay? So, in 1 kilometer, we have 1,000 meters. Okay? And then in 1 hour, we have 3,600 seconds. Okay, so cancel out c kilometer, then cancel out ch, you will be left with meter per second. Okay. So let's solve this using a calculator. That's 72 1,000 divided by 3,600. You will get 20 meter per second. So, yun na yung initial speed natin in meter per second. Okay, now to solve for your acceleration, we are going to use your formula. That's delta V over T. Okay, so your final velocity minus your initial velocity over time. So your final velocity here is 0 minus your initial velocity 20 meter per second divided by your time, that's 25 seconds. Okay? So ito, when 0 minus 20, that's negative 20 divided by 25, you will get negative 0.8 meter per second squared. I'll write it again. The answer now is your acceleration is negative 0.8 meter per second. So bakit negative siya? It's because the car slows down or nag-decelerate si car. Okay, so that's the opposite of acceleration. Okay? So here, your negative and positive would matter depending on the placement of your speed. Okay? Tsaka depende din siya sa problem. If from rest to speed or speed to rest, okay? So dun magva-vary if it is positive or negative. So yun yung importance ng sign when solving acceleration. Kapag bumagal ba or bumilis yung ating object or yung ating car.